Hey y'all, welcome back. This is the first video for lesson 8.2. This is the beginning of trigonometry, which for most of you will be the next course you take, Algebra 2 with trig. So this is sort of the beginnings of that. Even if you're not going to take Algebra 2 with trig, you're definitely going to see this part of it again in Algebra 2 or as you continue on through your math career. So we're going to start with just filling out some notes together. We'll use these to work through the rest of the lesson. Okay. So first of all, what is trigonometry? And I wrote here, it's just the study of triangle measurements. So specifically in right triangles, we're going to look at the ratios between the angles and particular sides. Okay. So we have three basic ratios. These are our basic trig ratios: sine, cosine, and tangent. Okay, for sine, we have the ratio of the leg opposite the angle to the hypotenuse. Okay, so for example, if we're looking at sine A, okay, see that's sine A. So for sine A, we're looking at the opposite leg over the hypotenuse. Okay, so the opposite leg is A, and the hypotenuse in this one is C. Okay. So the ratio of the sine A is equal to A over C, because that's the opposite over the hypotenuse. All right. So if we were looking, now also just it's kind of important as we go through this, we have lowercase letters and uppercase letters, and they matter. Okay. Big A is different than little a. Capital A, capital B, capital C, those represent angles, and lowercase ABC represents sides. So just be mindful of that. It's important how I'm writing that. Okay. So if we look at sine B, once again, this is the opposite leg. So the opposite leg of sine B is lowercase b, or little b, and then hypotenuse is still C. So sine B is equal to the ratio B over C. Okay? Cosine. So cosine is a different ratio. Instead of opposite over hypotenuse, this is the ratio of the adjacent leg, to the hypotenuse. So for example, cosine A, so start with A, would be the adjacent leg, little b, over the hypotenuse. So we would have B over C. And then the cosine of B would be the adjacent leg over hypotenuse. So A over C. Okay. So notice quickly that the sine of A over C, is the same as the cosine of B. It's interesting. It may come up again later. Also, sine of B over C, is equal to the cosine of A, B over C. So, not a coincidence. That'll come up. That'll pop up later on. Okay. The third one is the tangent. So, the ratio of the leg opposite the angle to the leg adjacent to the angle. Okay, so tan A, or tangent of A, is going to be the opposite leg over the adjacent leg. So A over B. And then the tangent of B would be opposite over adjacent. Opposite is B, and adjacent is A. Okay, so this is how we write those ratios for sine, cosine, and tangent. All right, now there's a way that we can remember these, and this kind of seems silly, but it's pretty helpful. So I'm going to write down SOH, Ka, CAH, TOA, TOA. Okay, so Ka, TOA. So SOHCAHTOA TOA is just a silly little thing. You need to get that stuck in your head, and it'll help you remember that sine is always opposite over hypotenuse. Sine is opposite over hypotenuse. SOH. So, SOH. Sine opposite hypotenuse. Cosine is always adjacent over hypotenuse. Cosine, adjacent, hypotenuse. CAH, Ka. So, Ka. And then TOA, tangent is always the opposite side over the adjacent side. So katoa helps us remember the trig ratios. Okay, like I said, kind of a silly thing, but I think it'll be helpful if you try to commit that to memory as we go forward. Okay. So I'm going to scroll a little bit. Now we have a few examples. The directions here say, give each trig ratio as a fraction in simplest form. Okay, so I'm not going to do all these. We'll just work through a few of these together, then I'll leave some for you to do. The first one says the sine of A. Okay, so find A. There's angle A, and it's equal to the opposite leg over the hypotenuse. So the sine of A is 5 over 13. All right. Cosine of A. Cosine is always adjacent over hypotenuse. So that's going to be, oops, I'm looking at C, sorry. Cosine of A is going to be 12 over 13, adjacent over hypotenuse. Okay. Tan of A is always opposite over adjacent. So 5 over 12. Okay. Now, you're doing this now and you're like, that's really easy and I don't understand why we're doing this. Stick with it. It's going to make sense as we go through this, like sort of most of the things we do. The more you do it, it'll start to kind of fill itself out in your brain. So just stick with it. Keep going. Okay. Let's flip to sine C. Okay. So here's C. Sine is always opposite over hypotenuse. So the opposite of C would be 12. Hypotenuse is 13 again. So 12 over 13 is sine of C. Okay. Cosine C is going to be adjacent over hypotenuse. So 5 over 13. And then tan of C is opposite over adjacent. 12 over 5. Okay. Now, with the first example, all three sides of the triangle were given. Okay, but here in example 2, we can see that we don't know what the hypotenuse is. Well, if we're going to write trig ratios for sine and cosine especially, we have to know what the hypotenuse is. So I'm just going to take a second and hopefully we remember that anytime we're missing a side of a right triangle, we can just use the Pythagorean theorem to find the missing side. Okay, so 9 squared is 81, 12 squared is 144, added together, that's 225. And if I take the square root of both sides, I get that C is 15. Okay, C is 15. So I'm going to write that in. Okay, and now this should be no problem. So sine of W, here's W. Sine is always the opposite side over the hypotenuse. So that's 12 over 15. Okay, but that can be simplified. 12 over 15, I can divide both by 3, and I would get 4/5. Okay, cosine of W. Cosine is always adjacent over hypotenuse. So 9 over 15 simplifies to 3 over 5. And the tangent of W is opposite over adjacent. So 12 over 9 simplifies to 4/3. And I know that's improper, but we're just going to leave that as an improper fraction. We don't really want to deal with mixed numbers here. So just 4/3 is fine. Okay, I'm going to leave these for you to do. Notice here, I'll just get you started. Pythagorean theorem would be 16 squared plus b squared, we're missing a leg, equals 34 squared. Okay, and when we evaluate that, we'll have to square this and subtract from both sides. You get b squared is 900. And when you take the square root of both sides, b is 30. So this leg is 30. Okay. And then we just look at these the same way. So the sine of L is going to be opposite over hypotenuse, so 30 over 34. That can simplify. I can divide both by 2. I get 15 over 17, and so on and so forth. Okay? Not too bad so far. We're going to flip to the second page here and work through a few more problems. Now it starts to look a little differently here on page 2 of lesson 2. So let's look at number 4 together. Okay, now you're absolutely going to use a calculator here. So make sure you have a calculator here that you can use. The note here says make sure your calculator is in degree mode. If you don't know how to do that, or if you don't know what that means, Google it with the model of calculator that you have, and you should be able to find that pretty easily. Okay, so here this is solve for x. Now clearly we're going to use the information that we just learned to do that. Okay, now I'm given one angle. The angle is 28 degrees. I'm given the hypotenuse, and x is the side opposite the angle that I'm given. X is opposite 28. So that means, if you think about it, I can either do sine, cosine, or tangent. Okay, but what I'm given to use is the opposite of the angle and the hypotenuse. Well, opposite and hypotenuse are used when we have sine, right? Sine, opposite, hypotenuse. So, okay, so I'm going to write the sine of 28 is equal to the opposite, which is unknown, over the hypotenuse. So sine 28 equals x over 19. Okay, so here we can just work on solving this. So I would multiply both sides by 19. So over here, if I multiply by 19, these two cancel out. So I have just x. And then I would have 19 times sine of 28. Okay, now we're going to go straight to our calculator here. And when I type in, now depending on your calculator, you may have to Google this and figure out how exactly to use it. I'm going to type 28 sine. Mine asks that you do the sine button after. If you're using the TI calculator, the TI-30X2S, whatever it is that we were using in class, you're going to type the sine button first and then 28. Okay, but either way, you should get the same answer. This 4.46947 and so on and so forth. But don't forget that we're multiplying both sides by 19. So I'm also going to type in times 19, and I get 8.9. We'll just round to the tenths. That's what the directions say. So I have x is about 8.9. Okay. Now this is going to be an approximation. I guess I should have used little squiggles instead of equal sign, because this is approximately 8.9. Okay. Now, I just want to point out real quick that we do not want to use cosine here, because we don't know what this side is, and that's the side that's adjacent to 28. So cosine wouldn't help us here. Tangent would not help us here, because we have to use the hypotenuse. That's what we're given. So we want to make sure that we use the hypotenuse. Okay. All right, let's try number 5. So number 5, I'm given 41 degrees. I'm not given the hypotenuse, which is across from the right angle. Not given the hypotenuse. So that means I have opposite and adjacent. This is obviously a tangent problem. Okay, tangent is always opposite over adjacent, right? So I'm going to say, let's write tan of 41 is equal to the opposite over the adjacent. Okay, so if I multiply both sides by 32, I'll have 32 times tan 41 equals x. That 32 will just cancel out. See, when I multiply here. So multiply both sides by 32. Okay, so then we go back to our calculator. I want, oops, I wrote 4, that's 41. Okay, I want the tangent of 41 times 32, and I got 27.8. So x is approximately 27.8. Okay. Let's see. Let's look at we'll do a couple more. Let's look at number 6. Okay, so I'm given 21. I have the hypotenuse and a side adjacent to 21. Sounds like cosine to me. Cosine is always adjacent over hypotenuse. So cosine 21 equals x over 26. Same thing, multiply both sides by 26, and I would be left with 26 times cosine 21 equals x. So get my calculator back over here. I've got cosine 21 times 26, and I'm going to round, so that'll give me x is approximately 24.3. Okay. Let's see. Let's do. Well, I'm going to skip 7, 8, 9. I'll leave those for you to try. Trying to see if one of these may be a little different. Yeah, actually, let's do number 8 together. Okay, so this is I have the opposite and the hypotenuse are the two that are marked. So this is a sine problem. So I'm going to write sine 33 degrees. That's the angle. Sine of 33 equals opposite over hypotenuse. Okay, now this is kind of an interesting problem. There's a couple ways you could go about working this. The most direct way, though, I want to get that x in the denominator is kind of a problem. So I want to move it to the other side so that it'll be outside the denominator. So if I multiply both sides by x, those cancel. So now I have x times sine 33 equals 15. Okay, well, I want x by itself. So I'm going to divide both sides by sine 33. Which is great news over here because these two cancel out and I have x. Okay, so now in my calculator, I want 15 divided by, now you may need to use parentheses, 33 sine, parentheses, close parentheses, equals, and I got 27.5. And again, that's approximately 27.5. Now, another thing you could have done, if you don't have parentheses on your calculator or whatever, we could have done sine 33, and that's about 0.54. Okay, then I could have typed in 15 divided by 0.54, and you get it's a little different because we're not using because we rounded instead of letting the calculator do it. The calculator takes the decimal point all the way out here, so when we round with a tenth, it's going to be a little different answer, but it's close enough, I guess, on these. Okay, so that one was a little different because up until now we've had a number in the denominator. Here we had an x in the denominator, so we had to first multiply both sides by x, then divide by the trig function on both sides. Okay, so that makes it a little bit different. I'll do one more of those. I'll do number 9, and then I think you've got plenty of these that you can practice on your own on the following page in your packet. But let's do number 9 together. So this is a cosine problem because we're given adjacent and hypotenuse. So I'm going to write cosine 43 equal to 36 over x. Okay, so if I multiply both sides by x, I have x times cosine 43 equals 36. And then I'll divide both sides by cosine 43. Okay, so those cancel. And then I'll go back to my calculator. So I want to type in 36 divided by parentheses, and I'm putting 43, cosine of 43 in parentheses, close parentheses, equals, and I got 49.2 is approximately 49.2. Okay, and that may look different depending on which type of calculator you have to work with. All right, so there's a couple word problems at the bottom. Let's skip down to those. Let's look at number 12 real quick. It says Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Okay, so imagine the ground, his house, the ladder. We're assuming right angle there. This is 68 degrees, and the ladder is 12 feet. All right, so the question is, how far from the house did we place the ladder? So this is the unknown, right? 12-foot ladder, distance to the house is unknown, but we're at a 68 degree angle. Okay, I have the hypotenuse and I have an adjacent leg, so this is going to be a cosine problem. Cosine of 68 equals adjacent over hypotenuse. Okay, now I have a number in the denominator, so this one's easier than the others. I'm just going to multiply both sides by 12. So x is 12 times cosine 68. I'll grab my calculator and type that in. So I've got 68, the cosine gives me that, times 12 of approximately 4.5. So x is about 4.5 feet. Okay. So I think you should be able to do number 13 as well. They're very similar. It says a ramp is used to load suitcases. We want to know how long the ramp is. Okay. It says if the cargo door is 7 feet from the ground. Okay, so we have the ground, 7 feet. We want to know how long the ramp is, and we know that we've made a 25 degree angle. Okay. So find how long is the ramp, which is we're finding the hypotenuse. Okay, so this is the sine problem because I have opposite and hypotenuse, so I would write sine 25 equals 7 over x, and then it's worked out just like numbers 8 and 9 at that point. So I'm going to let you give that a try. You want to make sure you get plenty of practice on the pages following this one. Please submit questions that you have or problems to my email. So you can email me at jmpate@tcss.net. Okay, or obviously you can send a remind if you would rather do that. All right. Good luck with these problems. Let me know how I can help.